Hello everyone, welcome back to the Gaming Networks class. In this learning unit, we will basically try to learn about more specifics network architectures that are designed for basically the digital gaming, and we are look into different aspects of these kinds of architecture and especially the security that you would have to deal with when designing gaming networks. If you look at the web game paradigm, a web game is basically a game that is hosted on a web server and it's accessible through a website. And you can play that website, a web game through a web browser. There are tens of thousands of these kinds of games on the internet, from the games that are on the Facebook or just simple little games here and there that have applications for specialized kind of websites, or even just general purpose drag and drop or click here and there kinds of games. There's one thing with all these different kinds of games out there that is basically clear, and that's web-based games are very popular. And in fact, if you open a web browser, you basically would have noticed that there probably like every 3 times that you open a web browser, you're being asked to play a little game. As I said in the previous lectures, there are special kinds of technologies that go into networking that have to deal with multimedia. And the reason for that is because the multimedia is expensive, is huge in terms of size, and of course there's a lot of special techniques and tools that are needed to applications that deal with multimedia. And games are one kind of multimedia system that you would be dealing with. And so, since they're also fun to play, they're even more popular than just general purpose multimedia networking. We will basically talk about the client-side technologies that you would basically see in games that are multiplayer and are accessible through the web. And we'll see what kind of technologies are used. If you look at this table here, you would notice that we have 4 different kinds of technologies that are used to develop web games, and these are created basically using different kinds of platforms. The platform that you would use has a big implication as far as the programming language that you would have to use to create your games with, and also a way to compile this game into a content that's publishable on the internet and on the web especially. To interact with the game with the website, you usually need a virtual machine that uses that compiled content, and it'll be essentially installed on your client machine, which will be your computer. And it's a software that your web browser uses to render the compiled content of the game. Probably the most famous kind of virtual machine is Adobe Flash virtual machine, or as we call it, the Flash player. Java, Shockwave, and Unity are more powerful than Flash player when you want to look at capabilities at runtime performance. But Flash is probably the most used platform for creating web-based games. Flash is basically has much lower learning curve, as you can see here in this chart. It basically bridges the gap between artists and programmers very well. Has a wider installation base and for virtual machines, and also its deployment and development is much easier than the other platforms. For this class, basically, we assume that these games and virtual worlds that we will be dealing with are played through a web browser. But we don't have to actually assume that. You can with the techniques and technologies that we will be using here, you can actually deploy your games in any kind of setting. If you look at the Flash content in Flash games, you can download them and run outside of your web browser from your hard drive. And there are several ways to do that. You can either run them as an SWF file. An SWF file is basically a file that you can download and run from your hard drive. this basically is an ideal, but it makes your application platform independent, and people from different using different hardware can use this system. For Windows, you can also run your Flash development as a Flash project, and then you can compile it into an executable file, and this file can be run. Or you can use the Adobe Air platform, which is basically the most preferred way to prepare Flash content and using users' machines. We will get into the details of these a little bit later. So where does multiplayer gaming fit in this case? While web games are popular for as long as you can remember web being there, multiplayer web games basically took a little bit more longer to grow in terms of their numbers. And this was primarily because of the fact that Flash was the most used platform in which the web games were developed, but many Flash developers didn't really have any way to program or didn't have knowledge to program multiplayer games. And for those who did, they did not have the server-side technology that was available for them to basically deal with the time requirements and the functionalities that the multiplayer game requires, as opposed to just a single-player web-based game. Since Flash Player 4 in 1999, multiplayer games have been possible in Flash players, and Flash Player 5 introduced the ability to establish a socket connection with the remote server. We'll talk about socket servers and socket connections a little bit later. That will kickstart your multiplayer game development. And in 2006, multiplayer game development in Flash was finally basically taking hold and was becoming more and more popular for development, basically. And there were more clients that were asking for from the developers to produce these kinds of games. In 2007 and 8, a couple of years ago, there were a huge explosion in the demand on multiplayer Flash games in virtual worlds. And with the advent of social networking, Facebook, these became even more popular. So if you look at where multiplayers Flash games or web-based games in virtual worlds fit into the web landscape, it's basically right in the middle. It's almost every development technology request that you can look in the market has some form of multiplayer component to it, and the multiplayer content are also very much sought for by the gaming companies or by general purpose web companies. So we'll look at classifying web games into some general categories and try to see why a multiplayer game essentially is to be made. So if you look at these categories up here, you would notice that there are different ideologies, different reasons behind creating a multiplayer game. One of the reasons would be, for example, if you wanted to generate ad revenue. For example, if you wanted to make more money and make your ads to have more impressions on your customers, you try to attract as many players to your site as possible, and then also you want to keep them on the site as long as possible, generate a large number of people who would be looking and seeing your advertisements. Many sites rotate some banner ads on top of a web page while the game is being played, and so this way, while people are in game, they might see different kinds of products, services, and so forth, and this essentially would ask the question how a multiplayer mechanism can help here. If you can basically keep users around longer, then you can achieve the goal of users seeing a potential ad that they need to or that they were interested in. And in fact, by the capabilities of chat in the game, multiplayer games, people can also talk about these things, and so the word goes out. You might want to make your site even stickier, and for people to wanting to go in your site, and even if it is non-game website and has non-game content, if you wanted the visitors to stay longer in your site, you can actually plug in here and there simple little games and have them stay in the site for a little bit longer. So how multiplayer technology can help here? In this particular case, the goal is to get users to use the game in your website for a while and then browse your website, since the goal isn't basically just playing the game, but it's rather for them to be there. And it's thought it's basically very, very hard to see how multiplayer capabilities of this kind of technique would help, but basically there are certain kinds of ways that you can make your users communicate with each other during that game session. Games also are often used to promote things like movies, like TV shows, like consumer products and events. Most of the games that certain kinds of multiplayer web-based game companies create fit this kind of category. For example, if you go to any movie website that is being released in the future, there's a flash game component to it that you can go and learn about the movie, see little trailers here and there while playing the content. Another reason for deploying multiplayer web games is basically to drive downloads. The casual game download market is very big, and also it's very successful. There are sort of sites like, for example, RealArcade.com, BigFishGames.com that promote many of their downloadable games with free lightweight web games. The idea is for the people to try the web game and get a sense and the taste of the game, and then want to be or to become interested enough to download your full game and content. There's a certain kind of gaming which is called serious gaming, and it's used not just for fun, but rather for education and serious issues such as healthcare and so forth. And the goal here is to make the education more fun, and by creating really interesting gameplay. This is basically a very difficult task, but you can find and manage to find a balance between the fun of the game and also the education part of it. And so you can make your games more engaging and people to learn about technology, about the topic that you're trying to convey. There's also the idea of providing subscription value. By paying a monthly subscription, users can gain access to regular new features and content within your website, and this approach can be basically successful. And you can see many virtual worlds such as Club Penguin, Faraway Friends, and so forth that use this kind of technology or multiplayer gaming to achieve what they needed as far as reaching their subscription bottom line. All right, now that we learn about the fact that you can use multiplayer gaming for a number of different reasons, and that it's essentially a nice way to get a discussion going and get people interested in special kinds of topics. We will need to see at the technology that's core to creating web-based games or multiplayer content, and that's essentially connecting your users. Think about the multiplayer application that you want to create and how popular you hope it would become. What probably should come to mind is a virtual world or a game lobby system that's bustling and it's alive with constant activity. Users can join and leave frequently. They can chat and they can interact with each other very easily. How do these users get information about each other? Are they directly connected to each other, or is something else going on? Now, in this part, or in this section, we'll try to learn about the techniques that you can use and you can establish, and talk about the most common way that you can make the interaction between users happen. And we'll learn about the technology that we will be using for the rest of this class when it comes to deploying and developing our projects. Before we start talking about anything else, we need to look at how we can connect users. And there are basically special kinds of techniques that you can use to connect people with each other over the network. In order for anything to take place in our case, we would have our clients or our players to be able to get information about other clients or other players, and also to be able to send information that can be seen or described by other clients. Typically, clients would interact with each other in two primary ways: peer-to-peer and client-server. Peer-to-peer is basically a fully connected network or even a sub-network that all of the clients connect to each other, and they would be basically peers to each other. They can directly speak with each other and send information back and forth. In client-server setup, clients communicate with each other, as you see at the bottom picture here, through a server, and the server is responsible for managing all of these connections and sending and transmission of all the client data. Peer-to-peer is when two or more clients communicate without the use of a server. A server may be used basically to allow them to find each other in the first place, but after that it's not going to be actively participating in the communication. Clients can exchange information by having every client connected to each other or to every other client. This technology is called a fully connected network, or a fully connected topology. Or by information passing through one or more clients as it goes along on its way to the destination client. This is called the ring topology. In here, basically, in our talk, we refer to peer-to-peer. When we talk about peer-to-peer, we assume that it's a fully connected topology, so we're not interested in ring topology. We talked about ring and token ring mechanism and network communication in the last unit. Generally speaking, in a peer-to-peer technology, it's not really a prime destination for gaming. In many cases, a game may appear to use peer-to-peer, but in reality, one of the players is essentially designated as a host and acts as a server. So, for example, if you remember the game Civilization 3 and 4, there was a hot seat gameplay mechanism that you could basically use a LAN or a multiplayer system, but one of the players would essentially, or the person who established and started the game, would be basically the server. But if you look at peer-to-peer topology and where it is used, it's mostly used for file sharing networks, and is also used to distribute patches for online games, for example, like World of Warcraft. This reduces the load on the web servers while speeding up the download of the patch or download of the files that are to be shared between players. The peer-to-peer technology would have two or a couple of actually advantages over client-server architecture, and it actually has severe disadvantages as well. Probably the most important peer-to-peer advantages is lower latency. Latency is the amount of time that it takes for a message to get where it's going. In a client-server message, the message moves from one client to the server. The server finds the other client and sends the message and directs it to the destination client. If you compare this with the peer-to-peer, the message goes directly from one client to another. If you have a directly or a fully connected network, it basically takes almost half amount of time that it needs to take to receive its destination compared to the client-server architecture. There's also no server needed, which means that in a peer-to-peer architecture, all of the clients are basically at the same level technologically and as far as the services that are being given to them, and there's no need to establish a expensive server and to be able to maintain and host and pay administration fees to keep the centralized server up and running. However, if you look at what we are missing, the fact that this peer-to-peer architecture is missing a server side process, it's basically suffering from certain kinds of disadvantages. One of the most disadvantages is scalability in gaming. When you're talking about games with a fairly small number of clients, you can basically make the case for using a peer-to-peer architecture because there's very low latency and there's no need for a server. But when it comes to a larger number of clients, let's say if you're talking about hundreds of clients or thousands of clients, then the peer-to-peer architecture would start suffering from the scalability. So you cannot really scale your game to a large number of clients in this case. It requires that individual connections be made for one client to every other client. So if you had like 1,000 clients, each client could establish and maintain 1,000 connections. But if you were looking at thousands and thousands of clients, then you would have to have a topology that requires a staggering amount of connections, and this in itself would make your case much weaker when you talk about latency. You also have to give some thought to see where this network can actually literally exist. If you had 1,000 clients, but they were all within a school's subnet, then that would be possible. But if you had 1 million connections, then you couldn't really host that connection on a subnet. And so you would have to have a special kind of network set up to maintain these large number of connections. Another problem that peer-to-peer architecture suffers from is decision-making resolutions and the logistics that goes into it. Imagine that you have a two-player peer-to-peer game. Each player can control a mouse and also is trying to eat the cheese. Player A approaches the first block of cheese and determines that he is close enough to eat that block of cheese. Player A awards himself with points for eating the cheese and sends a message to player B indicating that the cheese has been eaten. Player B receives and processes this message and removes the cheese from its screen and updates the player A score. So this is good. Everything is just working fine. We don't have a problem. But what happens if player A and player B both are headed towards a second block of cheese? Within a few milliseconds of each other, player A and B both individually determine that they can eat the cheese. They award themselves with a score, and they send a message to the other player that they have eaten the cheese. In fact, when the other player receives this message, they would notice that, oh, by the way, somebody else has also eaten the cheese, and the two clients would have no way to agree on who ate the cheese first. This is a problem with the peer-to-peer architecture here. This is primarily caused because there's no central brain for making any decisions. There are some examples. If 2 kill shots are fired at the same time at the remaining players, who died first? In a racing game, who crossed the finish line first? Players that are racing to grab a key on the ground, who grabbed it first, that we just discussed here with our cheese block example. The best solution in this case is to use client-server approaches. Let the server maintain the important bits of game states, and decision-making would have to be done on the server side. And the clients would have to rely on the server to resolve any kind of conflicts of interest that is arising. To be fair to peer-to-peer architecture, one of the clients can be designed as a host to resolve these conflicts. If we do this, we introduce 2 new problems. If all important decisions are to be run through a specific client, then you start losing your lower latency benefit for this approach. A message needs to go from any other client to the client who's basically hosting the game. And so the second problem is that in peer-to-peer games, naturally, you would have security concerns because all of the important logic is run on one client machine and no validation is maintained within a central location. So if you move all of these important decisions to a single client machine, then that client is represented with a theoretical advantage over all the other clients. Basically, whoever is playing on the host client would see everybody else's doings and would be able to side with its own actions when a conflict arises. Flash Player 9 and less did not have any support for peer-to-peer architecture. Flash Player 10 introduced support for peer-to-peer architecture, and it uses a new communications protocol that's called RTMFP, or Real-Time Media Flow Protocol, which is used in peer-to-peer message transfer. This means that developers now have the ability to connect Flash Player clients directly to each other and run a peer-to-peer architecture. The Flash clients must first connect to an RTMFP capable server, such as an Adobe Stratus server, and basically that server aids in connecting Flash Player endpoints or Flash clients with each other. An endpoint must maintain a connection with the server to also be allowed to maintain connections with other endpoints. Using this server, in addition to creating games, you can actually share audio and video chat applications and have very low latency. Now, as I said, for certain cases, especially for games, you would have to rely on a more structured client-server architecture. In the client-server architecture, you would have all of your clients to connect and maintain a connection with a centralized location that we call a server. The server transfers all of the information to the clients. There are two primary approaches to this architecture to maintain and to resolve communications: polling and persistent socket connections. Persistent socket connections through the use of a socket server is the most common approach, and we will explain this later. Let's first try to look at the polling techniques. Polling is an approach that usually doesn't make sense in application, but in theory, it's a good mechanism and a good method to understand the basics of client-server architecture with. In polling, your server basically sits there and listens to the clients by asking each client what they need to do and requesting any update that they might have to establish in the flow of communication. For example, let's say that you have a chat room. A client can make a request to the server on a timed interval and to check for updates. For example, the client in our chat room sits there and every once in a while polls the server, for example, 2 times a second to check for updates. If there is any update from the server, then it maintains and updates its status. If not, then it goes quiet and waits until another time interval has lapsed, and then he asks again for the updates. This is an example that's illustrated here. It can also go the other way. The server can keep asking all the clients if they have anything to say and make all the necessary changes. At first, polling may not seem to be like a bad idea, but when you look at the scalability of your client-server architecture, you see that the polling may not make sense when you have a lot of clients, because if all of the clients would want to ask and poll the server for new updates at any given time, there are so many milliseconds in a second that clients can ask questions from the server without crashing it down to the ground. Also, if the server wants to poll the clients every once in a while, if you have 1,000 clients, then the time intervals for the server would be 1 millisecond per poll. But if you have 1 million clients, then basically your server would not have time to do anything else but just asking the clients if there's anything to be done or if they have any updates for it. Socket server is a technique and technology that can be used to resolve the polling problem. A socket server is a program that runs somewhere. Usually it runs on a physical server remotely, and it listens to connection attempts. The socket server accepts connections from clients, manages them, and intelligently routes messages between clients. Socket servers basically live on an IP address or a host name and listen for connections on at least one port. For example, your socket server may be hosted on localhost and listen on port 8999 for connection attempts. When a client establishes a connection with a socket server, they open a persistent socket connection with the server. Using this open socket connection, the clients can send information to the server, or the server can send information back to the clients without having to ask for any updates from them. There's no need for polling in this case or anything like that. Since the socket is open and is ready to be used, information is passed back and forth quickly between the client and the socket server. Assuming that the socket server has enough intelligence built in, the system can be set up in such a way to minimize the amount of data transfers. Some servers can also be used to group or aggregate client-bound messages. Aggregated messages are the messages that are grouped together and sent at once. To be fair, message aggregation can be used in the peer-to-peer networks as well, but they're primarily used in client-server architecture. Some commercial socket server products, such as Electro Server, that we will be using throughout this class, allow message aggregation to be turned on so that you don't have to program this feature by yourself. To get a sense of the event-driven nature of the socket server applications, imagine that you have a chat application. If nothing happens over 5 minutes, there is no connected connection attempt and no information transfer between clients and servers, or from the server to the clients. Therefore, no bandwidth is being used. If you compare this with the socket, with the polling, with the peer-to-peer example, you would notice that there's at any given time there's a persistent bandwidth that is being used. However, when something does happen, for example, if a person joins into the chat rooms, a person leaves the chat room, or a chat message is being sent, this information can be pushed by the socket server to all the connections who need to receive and see this update. Updates are event-driven, and therefore they are real-time. In this case, internet latency is still something that you need to deal with, and especially when it comes to games, you would have to deal with the latency that occurs. When it comes to choosing a socket server for your project, you have several choices. We list 3 of them here, and then we choose one to use in this class. The multiplayer concepts that we talked about a few minutes ago, and now that there comes for us to decide how we want to implement or how we want to use or go about writing our multiplayer contents, we need to look at different kinds of technologies that are there and which one makes more sense for us to use. Developing a socket server that is basically rich in features and highly scalable and actively maintained is a very difficult task and requires a long time commitment to server developers. Because of this, most companies choose to use an existing socket server rather than building their own. There aren't just many choices, and most of these socket servers are commercial. We'll look at 3 of them. Adobe Flash Media Interactive Server that you can download from www.adobe.com/products/Flash Media Interactive is intended to allow for greater interactivity between connected clients. The server version that we are concentrating at this point allows for customizable server-side scripting that could extend the functionality of your server. It also allows for streaming of audio and video signals, or basically high-definition video signals. It uses remote share objects to synchronize data on the connected clients. And also, it's free up to 5 connected clients. Red 5 is an open-source server product intended to be a direct replacement for Adobe's media server. Red 5 supports media streaming, remote shared objects, and nearly every other feature that Adobe servers provide. It's open source and therefore it's free. However, since it's an open source and free product, there are bugs. So you would have to basically know what you're doing, and if you encounter a bug, to be able to resolve that. Electro Server, we talk about both versions 4 and 5, can be accessed from ElectroTank or electroserver.com, and is free for up to 25 concurrent clients and requires a license for more than 25 users. Electro Server has been there for longer than the other socket servers, even more than Adobe products, and also is used for a significant number of virtual worlds and multiplayer games that are developed by Flash tools, as well as now having the support of C# platform and being able to use in Unity, which is a C# game engine or a C# based game engine. One of the primary advantages of using Electro Server is its massive scalability. It scales to hundreds of thousands of connected clients at the same time. However, to use that large number of clients, you would have to purchase a license for it. So, with these, we already talked about web-based technologies, client-server architecture versus peer-to-peer architecture. We'll look at the advantages and disadvantages of using each of these technologies, and we learn about socket server technology that allows you to establish a server connection with all the clients and save on having to ask the clients for updates every once in a while. And we decided that we would be using Electro server for our game development in the rest of this class. So with this being said, we would look at a very important issue in any multiplayer internet and web-based game that we would have to deal with, and that is security.